Welcome to Linear Programming Basics 2 tutorial. In this tutorial, we will learn how to use Excel to solve linear programs. In particular, we will learn how to set up an LP in Excel and then how to apply Solver. We will continue discussing exercise 7.3 on page 398 of the Data, Models and Decisions textbook. Previously, in tutorial 1, we discussed this problem, we formulated it as a linear programming problem, and solved it graphically. Recall that in this problem we had an artist manufacturing vases. The artist had a limited amount of time, 2,400 minutes per week. He had limited material and limited storage. He had to decide how many small and how many large vases to produce so that his profit would be maximized. The overall optimization problem therefore read max 10s plus 12l subject to 20s plus 20l less than or equal to 2400, 10s plus 20l less than or equal to 1600, 2s plus 3l less than or equal to 260, and the non-negativity constraints. The first thing I do when transcribing a linear program into Excel, I usually reserve a row for the objective function, which I typically do in the second row of a spreadsheet. Below that, I reserve rows for each of the constraints. In this case, we have 3 constraints, one for the artist, one for the material, and one for storage. Finally, below that, I usually reserve a row for the variables, which typically I paint green. Similarly, I reserve a column for each of the variables. In this case, we have 2 variables, one for small vases, one for large vases. Next to that, I reserve a column for the equations, which eventually will become my left-hand side. Next to that, I usually reserve a column for the type of constraint, where I will later remind myself whether this was a less than or equal to constraint, larger or equal to constraint, or equal constraint. And finally, next to that, I reserve a constraint for the right-hand side. Now, the gray areas in this spreadsheet are simply the areas where I will add the coefficients and the data from the problem. For example, in this cell, which represents the objective coefficient for small vases, I simply enter 10. Similarly, the coefficient for large vases is 12. The coefficient in the artist constraint for small vases is 20. The coefficient for large vases in the artist constraint is also 20. The coefficient in the material constraint for small vases is 10, and that for large vases 20. The coefficient for small vases in the storage constraint is 2, and that for large vases 3. Finally, I have to enter my right-hand sides. The artist constraint has a right-hand side of 2400, the material constraint of 1600, and the storage constraint of 260. Now I remind myself what type of constraints those are. I simply type less, less, and less to remind me that those are all less than or equal to constraints. Here you have to be a bit careful. If you have an equal constraint, you cannot type equal because then Excel thinks you are trying to enter a formula. So if I have an equal constraint, I usually set that into apostrophes. Now we actually have to do some work. We have to enter the equations. Well, the actual objective function reads 10s plus 12l. Since my variables will be stored in cells B6 and C6, I will type here equals the sum product of cells B6 to C6, and that I do in absolute, so F4 or function F4, depending on whether you have a Macintosh or a PC, times the objective function coefficient, and I hit enter. Now all I have to do is pull this down, and I have the sum product here for cells B3 to C3 times B6 to C6. So this reads 20 times S plus 20 times L. And similarly, here I have the material constraint. And finally, here I have the storage constraint. Just to check that I did this right, I actually enter some values here. Let's see if we enter 1 and 1. Now 10 plus 12 equals 22, 20 plus 20 equals 40, 10 plus 20 equals 30, 2 plus 3 equals 5. Yes, this is correct. Let's do one more check so that we understand this. Now the objective function would read 2 times 10 plus 1 times 12 equals 32. The artist constraint would 2 times 20 plus 1 times 20 equals 60. Material constraint would be 2 times 10 plus 1 times 20 equals 40. And finally the storage constraint would read 2 times 2 plus 1 times 3 equals 7. So we did all this correctly. Here I pulled this down too many times. I erased this again. And now I have entered the data for my linear program. Notice here on my left-hand sides, this is my objective function value, the value I want to maximize in this case. Now I'm ready to go to data and to solver and enter the linear program here. My target cell is cell D2. I want to maximize this. I want Excel to change cells B6 and C6 for me, my two variables, and then I will add the constraints here. My constraints are that D3 has to be less than F3, D4 less than F4, and D5 less than F5. So I put on the cell reference on the left hand side D3 to D5, and on the right hand side simply my right hand side here. Hit OK. These are all my constraints. However, I still need to add the non-negativity constraint, so let me go to options, and here it is important first of all that we assume a linear model. Otherwise Excel will not solve this as a linear program, and we first of all cannot be that certain of the outcome, and second of all the output will be different and less meaningful. We don't have to really worry about this very much here, but assume non-negative. Yes, we have all variables have to be non-negative. The other solver options we don't care for at this point. You can read up on these independently on literature on solver, but for most practical purposes at our level we don't need to concern ourselves with those. We hit OK, and let's solve this problem. Yes, we keep the solver solution. We want to have the answer and the sensitivity reports. Hit OK, and we have two more worksheets. One is the answer report, and the other one is the sensitivity report. Within our spreadsheet, The variables are now our values 120. Our optimal solution value is 1240. We see from the solution that the artist constraint is satisfied, or tight, I should say. The material constraint is not tight, and the storage constraint is also tight. But it's easier to get these results from our answer report. So let's have a look at the answer report. This is what the answer report looks like. How to interpret it, we will cover in the next tutorial, Basic Linear Regression 3.